Okay, for lesson 2 on strings, let's just start with a summary of some of the methods we already know and some of the ones we'll learn. Now, there are many more methods than I'm presenting here, but these are the main ones that we need to know, the basic ones. So we talked about in lesson 1 the length method. So length is going to have you return to you the integer, which represents how many characters there are in the word or the string. charAt, a certain index, is going to give you the character found at that index number, remembering that strings start numbering their characters from 0. So to get the last character in a string, you would have to say charAt, the length of the string, minus 1. Now substring, briefly discussed before, has a starting and an ending, and it can pick out a piece of a larger string. And the tricky thing with this is that it's inclusive of the start number, but not inclusive of the end number, which can be a little bit confusing at first until you get used to that. Now, substring is a method that's overloaded, which means it has two different ways you can call the method. The method name is still substring. That's why it's called method overloading, because it overloads that name, substring. But you can see it's different based on the number of parameters that you give it. So this one takes a start and the end. This one just takes a start. So this version of substring starts at this number and goes to the end. Now, toUpperCase and toLowerCase, those methods are going to return a copy of the string with all of the letters converted to either lowercase or uppercase appropriately. The tricky thing here that I want to show you is that it returns a copy of the string, which means that it doesn't change the original string. So it leaves that one alone, but returns you a brand new string, which you can store in another variable if you want, or just print it directly. So here's some code that I wrote. We'll just take a look at the screenshot of it. But here, I'm just making a string, Thornhill, and I just want to demonstrate the length. So when I make an integer variable called len, and I set it to s, which is my string, these methods are always called from the object. So that's the object name is s for my string variable, and I'm going to call the length method on that. Okay, so now if you were to count those up, you would find that Thornhill has 9 characters in it, and that should give me value 9, and down here you can see that it does. Now, if we look at the next charAt, here we're saying give me the character at position 2. So the character at position 2 is actually going to be the O, because remember we start counting from 0. So the T is the 0th character, then H, then O. So if you look down here, the character at index 2 of Thornhill is O. So it's not the second character, but the character at index, whatever you specify here. Now, here's substring. So we're saying string part, and we're saying this part string is going to be returned by calling substring 1 to 5, not inclusive of 5, on our string s. So it's going to work with string s, and we're going to say find index 1, which if you remember 0, 1, that would be the h, and go to 5. So this is where it's tricky because it doesn't include 5. So it just goes 0, 1, 2, 3, 4, 5. So 5 is the h, but it's not going to include the h. So it should go and say substring of 1 to 5 is horn. So it includes the character at position 1, but not the character at position 5. It just gives horn. I'm going to make another string called end, and I'm going to use the other overloaded version of substring where you just specify a starting value for your index, and in this case I'll say 5, which we know is the h, and it's just going to go to the end, so that should produce hill. You can see down here it's hill. Now If I then start to try out these lowercase and uppercase methods, these ones are a little bit more confusing because what people tend to think is that when I call s.toLowerCase, it permanently changes this string s to the lowercase version. But like I mentioned before, it does not. It returns a new string, which we're going to capture in this other new string variable called lower. And it is a version of this one that's been all converted to lower. So when we eventually print that, it would print down here, the lowercase version of Thornhill is Thornhill. And when we eventually print the other one, where we've called toUpperCase, that's right here, it prints the uppercase version of Thornhill is all uppercase Thornhill. So yeah, that's when you store it in a new variable and you print that new string variable out. But here's the potential error that a lot of people get because strings actually never get changed, the original version of them. So if you do something, for example, s.toUpperCase, it does not change s, so it just returns a new string. So if you happen not to capture that string, like you just say s.toUpperCase, it does the uppercasing, but you don't actually store it in a variable, so that just gets lost, the returned value of the uppercase version. But a lot of people think, oh, if I do s.toUpperCase, it's converted this all to uppercase, and then if I go to print it, I think it got cut off here, but I did print it, and it says here, s.uppercase, toUpperCase just printed Thornhill, the normal way that it was originally there. So it didn't actually change it. You can try that out yourself. I recommend just, trying all this out on your own just to confirm that it works and play around with all these things. Okay, a few more methods to look at. Trim is fairly easy, just trims the leading and trailing white space. Okay, so that means anything before or after the string, starting looking at the beginning and the end, if anything is white space, meaning a space or a tab or some non-printable character, it'll just get rid of it. It's pretty handy for when you're getting user input and you don't want extra spaces to appear. Replace is going to replace part of a string, part of the original string with some new value. So we'll see how that works. So indexOf is really handy. It's one of the more important ones. It's going to find where a string is within another string, within the given string. If it doesn't find it, it returns a -1. This indexOf is another one that's overloaded. You can see there's two that I'm showing here. There's actually more than that. Some of them take a char instead of a string, but I'm not showing those. They're basically the same, but it's overloaded. This one takes a string only. This one takes a string and a starting position. This one will look for an occurrence of the string within the original one just from the beginning, whereas this one starts at a certain location and then starts moving to the right to look for it. If it is more suited to your task, you can also use lastIndexOf, which starts searching at the end of the string and starts going backwards until it finds it. Sometimes that's quite handy. So let's see a code example of trim and replace. So here I've just made this string called text, and I've put a space in front of some text, and then I've put a bunch of spaces after. And here I'm going to say, I just print out the original text, and I put these hashtag # things before and after just so you can see the spaces are there. And then after the trim, I've run text.trim, and I put those hashtags there. And you'll see that here's the original one with all the spaces. And after the trim, you can see the spaces in front and behind are gone, and it's left the ones in between. So that's, so that's what that one's done. Now, if I look at this one here, the second one just demonstrates where there's a tab at the end, and it will get removed as well. So when you print the original one, you can see the tab is there, and then afterwards I can see that it's gone. It's no longer there. So the last thing on this one is replace. So if I take my text, which is hey there, actually I think originally I must have changed this because it says my original one was hey there, hey. I think I wanted to demonstrate that when you run replace, so I did add another hey there just to show you that it does replace all, even though the name of the function or the method is called replace. It replaces all occurrences of hey and puts in this new text instead of that. Hey, I'm now saying hello. So this said hey there, hey originally. So, and now it says hello there, hello. So all occurrences of hey were replaced with hello. This is actually pretty handy sometimes if you want to replace all the spaces. So what you can do is you can say in my text here, replace any space that I had with emptiness, like nothing, right? So that will go through here and you can see this version's got no spaces. So the space that was there has been removed and the space after the exclamation mark has been removed, and any trailing and leading spaces are also been replaced. So it removes all the spaces. And finally, the last thing is taking a look at indexOf. So indexOf is a little bit tricky sometimes, but here's how it works. So if I have my word, Thornhill, and I have this integer for location, I'm going to use that later. I made this integer called first h, and I want to store, I want to call it from word, which is Thornhill, find the index of h within there. So it's going to start searching until it finds it, and it's going to find it in position. There's two of them, right? So it's going to find the first one, and then it can only return one thing. So it's going to stop when it finds the first one in position. That's position 0, position 1. So when I print first h, to say it found it in position 1. So if I want to do something like find, I can also just find words like hill in Thornhill. So when it searches for that, it will find here start of hill, and it will report where it found the starting of hill. So when you look down here, it says it found the index of hill within Thornhill at position 5. And you can double check that, but correct. Here's just a demonstration of what happens when you don't find something. So if you're trying to find Bill in Thornhill, it can't find it, so it returns a -1. Why does it return -1? Well, it can't. Why doesn't it return 99? Well, that could possibly be a valid location in a string that's really long. Why doesn't it return 0? Well, because 0 is an actual index. It's the first character in a string, so it can't do that either. So what they chose to return, and it also has to be an integer, right? Because once you say it returns an integer, it must return an integer. So it returns -1 because that's the first invalid number possible. So keep that in mind. It's handy to know, especially when you want to stop looping. Once you've found no more occurrences of something, you'd be looking for a -1 to come up when you call indexOf. Now, the next thing is, how do you find subsequent h's in Thornhill? How do I find the second one? Well, one way to do it would be to use the overloaded version of indexOf, and I'm doing that here. I'm saying location equals word.indexOf, but start searching from, really, I want to start from searching from position 6. So, but in a more general way, I want to start from 6 because, or actually no, I want to start from, okay, where I found it last +1, right, which is 0, 1, 2. So if I start searching from the O, I can find it here. The reason I just made this a bit more general is because it's just better than hard coding it. So first h is the location of where I found the first h. I have to add 1 so I don't keep finding the same h. So I'm searching from one position after where I last found it. And That one returns a 5, which is the position of this H, the second one. Another way to do that in this case, since there's only 2 of them, I could use lastIndexOf H, and I could start from the end, and it would go backwards until it found the H, and it would report it in position 5.